Now we're going to look at how we can put these into a graph. So a couple things is we can use our calculators or we can do this by hand. I'll go over both ways. So we're going to take this equation and we could solve it by calculator. So if we're putting in the calculator, let's use this -2, for example. So it's -4, and then in parentheses, and you do want to put the parentheses in the calculator, that's important. And then you would hit caret, and then we're changing this exponent to the -2. If you're doing it by hand, then that will be, it's going to give you a decimal answer. Then use your calculator to convert that decimal into a fraction, and you will get this answer. To convert it to a fraction, you hit second, and then the PRB button. If we're doing this one by hand, so let's look at the same one by hand. Then I'm going to take -4, 3 to the -2, and I have a negative exponent, so that means fraction. The -4 has a +1 exponent, so the -4 can stay in the numerator, but that 3 has to move down because it has a negative exponent and becomes positive exponent. And then -4 over 3 squared is 9. So I think one of the most missed things is we see that -4 and we think we need to move that. But that is an exponent rule. And -4 is not the exponent. Its exponent is technically a +1. And since the exponent is positive, we don't do anything with it. So we're just going to continue down. Now we're going to change the x into -1 and then into 0, 1, and 2 until we're all done. And we can do it by hand or we can do it on the calculator. I'll do a couple more by hand on this one. The next one we'll do a third way also. So we'll say we have -4, 3 to the -1. So again, if we're doing it by hand, it becomes -4 over 3 to the +1, which is really just 3. So we get -4 thirds. And then the next one, -4 times 3 to the 0. But anything to the 0 power is just 1. And -4 times 1 is -4. -4 times 3 to the first. 3 to the first power is just 3. And -4 times 3 is -12. And then the last one, -4 times 3 to the second power. 3 to the second power is 9. And -4 times 9 is -36. And again, you could solve this by hand like I did, or you can just put them in the calculator each time. Just make sure you're putting that 3 in parentheses in the calculator. All right, and then once we have all these points, we are going to put them in a graph. A couple things about the graph is we may need to count by something other than 1. So like if I look at this problem, if I count by ones, I'm not going to get that -36 here to fit on this graph. So I'm going to have to count by something bigger than that. But at the same time, I have some pretty small numbers here as well. So I don't really want to count by something too big. So normally I would say count by something that you can fit all of your numbers on the graph. For this lesson, I'm going to say that it will be okay if one and only one of your numbers just does not fit on the graph. If the other ones do, then you're okay. So I'm going to count by, let's see, 1, 2, 3, 4, 5, 6. I only have 10 spots on here, so I'm going to count by 2s. So I have an x is negative, let's see, so it's going to be 2, 4, 6, -2, -4, -6. When x is -2, my y value is -4/9, so that's just a little tiny bit down below. When x is -1, we get -4 thirds, which is really -1.3, so a little bit lower, but not by much. When x is 0, so we're here, when x is 0, the y is -4. And since we counted by 2s, the y is -4 right here. When x is 1, the y is -12. 2, 4, 6, 8, 10, that's going to be negative 12. And then the next one is going to be way off the graph. So again, if one of them is off the graph, that is okay. And then I'm going to connect those dots, and it's going to look like this. Let me fix that top part a little bit. So this top part here, this is what's new, and we're going to make a note about this. This is going to get closer and closer to that x-axis, but it's never actually going to cross the x-axis. When you get into Algebra 2, we're going to look at some different types of exponential equations where that will change. But for what we're going to do in Algebra 1, our graphs will never cross the x-axis. To make them cross the x-axis, you would have to have additional pieces to this equation that you learn about in Algebra 2. So if the graph is down below the x-axis, it is going to stay below. And I can show that by making this line come really close to the x-axis, but never going above it. And then it's going to shoot off in the other direction. And then all exponential graphs are going to have this curve. So it's going to start out changing slowly and then change real fast. Or it might change real fast and then slow down. All right. And then let's do the same thing again for this one. We can put it in the calculator, or we can do this one by hand. If you put it in the calculator, so let's do this 0 first. 10 times 2 caret 0. If you're doing it by hand, 10 times 2 to the 0, anything to the 0 is 1, so really that says 10 times 1, which is 10. And then the next one, 10 times 2 to the first. Exponents first, so 2 to the first is just 2. 10 times 2 is 20. I'll do one more by hand. 10 times 2 to the second. Well, that's really 10 times 4, because 2 squared is 4, and that is 40. Okay, and then, so the third way I said we can do this is, because it's exponential, like we learned up above in video part 1, we're multiplying by the same value. So if I look at this, there's a pattern here. I'm multiplying by 2. 10 times 2 is 20. 20 times 2 is 40. So I can just continue that pattern. 40 times 2, this must be 80. 80 times 2, this must be 160. So there's just another way. Once you see that pattern, you can use that pattern also to help you complete your table. That's also a really good way to check to make sure you don't have any errors in your table. All right, so if I definitely don't want to count by ones on this one, because I won't fit anything but maybe 1 or 2 on the table. Let's count by tens on this one and see if we can get 160 in there. So I'm just going to put a few numbers on here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 30, 140, 150. There's 160. So even though I didn't write every 10, I am counting by tens. I just skipped a line since it's so tiny. All right, now I'm going to start plotting those points. So the first one, when x is 0, the y is 10. Next one, when the x is 1, the y is 20. So it went up just a tiny little bit. When x is 2, the y is 40. It went up a little bit more that time. When x is 3, the y is 80. So again, you can see them starting to get more spread out. And then when x is 4, y is 160. So again, even more spread out. If we can kind of see this curve to it, make sure we put arrows on both sides. So there's an arrow on this side down here also. But remember we said that this graph is never going to go. So if I had below the x-axis, so if I had extended this line out, if we did have some negatives here, it ended up going this direction, where it's going to get really close to that x-axis but never actually cross the x-axis. So every exponential is going to have this curve. The graph will curve. Even if the points you have, it doesn't look like there's a curve, it really will curve, and make sure you show that curve when you're graphing it. Even like this one, if you have to make that extra part of your line to show the curve. Make sure it curves. Make sure you have arrows on both sides. And then again, if one point doesn't fit on the graph, that is okay. But if you can, try to count by something so that you can fit all your points on the graph.